Hello, and welcome to Chapter 16 Energy, Video 3. By the end of this Video 3, you will be able to explain what kinetic energy and gravitational potential energy are. And you will be able to perform calculations for kinetic energy and gravitational potential energy. Okay, so what do you see here? You see a picture of a dam with water behind. And of course, the water here is higher than the water here. Yeah. So imagine that if the dam releases water, the water here will start moving and travel downwards. Yeah. So, and that is because the water here in the upper part of the dam is at a height above the lower part. Okay. So we say that this water possesses gravitational potential energy. Okay. So gravitational potential energy is the energy that an object possesses due to its height or position above the ground. Okay, it is calculated by the formula P equals to mgh. Now, for this formula mgh, the mass must be in kilograms, g must be the acceleration due to gravity, 10 meter per second square, and h is the height above the ground in meters. Now, using these units, the potential energy will then be in joules. Okay, so just make sure mass is in kg, height is in meters, and g is 10 meter per second square. Okay, so let's look at an example 3. Okay, so in order to understand the formula mgh, what does it actually tell us? Okay, so I've got two objects, A and B. Both are at the same height above the ground. Okay, and but we notice that B has a larger mass than A. So which object has the larger gravitational potential energy? Okay, so let's look at the formula. Okay, so formula for the gravitational potential energy is mgh. So for the mass of A, mass is 10 grams equals 0.01 kilograms. So we substitute this value in the formula for the gravitational potential energy of A. So here we have mass is this, G is this, and we say we let the height be h. So the PE in terms of h is 0.1 h. Yeah. And of course, for B, since the mass is twice that of A, so I expect that the gravitational potential energy of B is 0.2 h, which is twice that of A. Okay, so since both objects are at the same height, and since B has a larger mass than A, so that will mean that the gravitational potential energy of B is larger. Okay, and then this is not surprising, because if H is the same, G is the same, if M goes up, then the potential energy will go up as well. Okay, right, so let's continue with the other part of example 3. Now here I have two masses, A and B, and now A and B have the same mass, but A is at a larger height than B. Okay, or A is further away from the ground compared to B, so that means that A has a larger value of h. So with the same reasoning, if both have the same mass is the same, G is always the same at 10. So if h is larger, then the potential energy must be larger as well. So we do not need to perform any calculations. We can straight away see that A has a larger gravitational potential energy simply because it is further away from the ground. Okay, so now that we've discussed gravitational potential energy, let us discuss kinetic energy. Now, kinetic energy is energy due to motion. It can be calculated by the formula half mass times v squared. Okay, so we must specify that if the units of kinetic energy are to be in joules, then the mass m must be in kilograms and speed must be in meter per second. Okay, so now here I have two objects. Which object has a larger kinetic energy? So I notice that both have the same speed, but B has the larger mass. So because we can quickly argue that, see, if V remains the same but M is larger, so that means that KE must be larger. Yeah. Okay, so that's what I'm saying here. So if B has a larger M, that means that B must have the larger kinetic energy. Okay, so then let us try some calculations here. The kinetic energy of B, just half times its mass times its speed square. Okay, so that don't forget the square here. Okay, the square must be present. So once you multiply it out, okay, you get 2,700 joules. Okay, so now for the next part of example 4. Okay, which object has the larger kinetic energy? Okay, so you look at the the two objects again. Now both of them have the same mass, but B has a speed that is twice that of A. So, same thing, let's look at the formula for kinetic energy. M is the same, but V is larger for B. Okay, so that means as V is larger, then kinetic energy increases. So that means B has the larger kinetic energy. Okay, so simply because it has a larger speed now. So the kinetic energy of B, so let's see the substitution again. Alright, so I have a typo here, so let me get rid of it by taking the pen. So I don't need my pen here. Okay, so I will get rid of this. Okay, so there's no square here. Yeah, so very good. So now we have a case of kinetic energy will be half times its mass. Oh no, this is not 600, this is 300. Okay, so let's write that correct. Okay, alright, so half times 300 times 6 square is equals to half times 300 kilograms times 6 meter per second square. Meter per second, the whole thing square, is equals to not 10,800 joules as I've typed out here, but actually 5,400. Yeah. Okay. So there we go. Yeah. So that should be the case here. Okay. So that's just another sample calculation for the kinetic energy. Okay. So let's go back to example 3. Now, in the next example, example 5, we are going to consider what is happening to the falling ball. Okay, and so of course, if I have an object at a height here, then it will drop. Yeah. Okay, so now we are ready for example 5. Okay, so for a falling object, the conservation of energy applies. Okay, what is the conservation of energy? You will know it as energy cannot be created or destroyed. It can only be converted from one form to another. Another way of expressing it is to say that the sum of the gravitational potential energy plus kinetic energy is the same at all times. Okay, so now this assumes that friction is not present, and for most cases, it can be ignored. Okay, so now we are ready for example 5. Okay, so if we have an object of mass 1 kilogram is held stationary above the ground. Okay, 2.0 meters. So calculate its gravitational potential energy. So it's a simple case of taking the formula and substituting the values. 1 kilogram, 10 meter per second square, 20 meters. So that gives me 20 joules. Okay. So when it reaches the ground, what will its kinetic energy be? So if I'm stationary 2.0 meters above the ground, okay, I've just calculated that my gravitational potential energy is 20 joules. Whoa. Okay, let me just erase that. Okay, yeah, I've just calculated that my gravitational potential energy is 20 joules. Okay, and since I'm stationary, my kinetic energy is 0 joules. So my total energy will be 20 joules. Yeah. Okay. So now the next part of the question says that when it reaches the ground, that means to say I drop the ball and the ball falls and gets faster and faster, right? Okay. So just before it reaches the ground, okay, just it reaches the ground, so it's at the ground, right? So its potential energy is 0 joules. Okay. Now, just now I said that the total energy, the sum must still remain the same, right? Or it remains the same at all times, 20 joules. So that tells me that my kinetic energy must be 20 joules in order for the total energy to remain at 20 joules. Okay, so that was my answer here, is that the kinetic energy is now 20 joules. Yeah. Okay. So this is like the conservation of energy. Yeah. So the P here, potential energy here, is converted to kinetic energy, and the total energy remains the same. Okay, so now when the ball drops and just before it reaches the ground, it will have a speed, right? Okay, so we now know the kinetic energy, right? So we can use the value of the kinetic energy to calculate the speed of the ball. Okay, so the speed of the ball, okay, is v. Let the speed of the ball be v, and the formula for kinetic energy is half mv squared. So we substitute the numbers that we know inside the formula and let it equals to 20 joules. So we simplify, that gives us half v squared equals to 20, or bring the half over, v squared equals 40. So now we make v the subject, okay, by taking the 40 and the square root of 40, and that gives us the speed of the ball just before it reaches the ground to be 6.32 meter per second square. Okay, so this is a simple example of our conservation of energy. Okay, the sum of GPE, the gravitational potential energy, plus kinetic energy is the same at all times. Okay, right. So in summary, the gravitational potential energy is stored energy of an object due to its height and is calculated by the formula mgh. Okay, so you must remember what the units of m and h are in order for the units of energy to be in joules. Same thing for the kinetic energy, is due to energy due to motion. Formula is half mv squared. Remember the units for v and the units for m. Alright, so this is the end of video 3.